Hi students, welcome to video 27 on energy basics. So looking at the history of energy in the United States, for most of human history we have used wood to burn for heat, cooking, all those sorts of things. This peaked in about the mid to late 1800s. About the late 1800s is when we discovered coal and we started burning coal for energy instead of that wood. It gave us a lot more energy. And then oil and gas peaked around the 1960s, 70s area time period. And if you look down here at what we are still using, you'll see that oil is the number one thing. You'll see that it went down significantly here. We'll talk about what that was from in just a little while. But we're still mainly using oil. We're also using a lot of natural gas, and we're also using some coal, even though that has declined some in the past. And then you'll see nuclear, hydro, solar, those sorts of things are down here. Still have a long ways to go and a lot of potential to increase in our uses. So the thing that happened in the 1970s that you saw that little dip in oil, also kind of the equivalent of natural gas, was called the OPEC oil embargo. So basically the OPEC countries, which are a lot of Middle Eastern countries, you'll see down here a list. You do not need to memorize these things, but just kind of know a few of them. Kuwait, Saudi Arabia, are some of the traditional ones that we think about with oil. So basically what happened is there was an embargo against any countries that were supporters of Israel. So what that caused was a price increase from about $3 globally a gallon to about 12. And it depended on where you were, how much the price was. So this was a very scary situation. It led to a good thing, actually, the rise in alternative energies, because we were forced basically to find some other method of getting energy. We also developed something called CAFE standards, which is Corporate Average Fuel Economy. Make sure you know that acronym. And so basically companies were required to start doing fuel efficiency, which they had not in the past. So no more 8 to 10 miles per gallon cars. We were looking for more like 20 to 30. We started using smaller cars because they were usually more efficient. We also had a national speed limit of no more than 55 miles an hour, because most vehicles are going to be more efficient at that speed than something like 70, to 80 miles per hour. So looking at a few basic things about energy, a lot of this is going to be review for most of you, but some of you may not have worked with calculations as much. So a formula you need: work equals force times distance. And when you get this calculation, it's measured in joules. Power is energy divided by time. It is measured in joules per second, also known as watts. And 1 kilowatt equals 1,000 watts. Now, most of the time, if it's any kind of weird calculation or unusual units, you will be given those. Kilowatts to watts conversion is not going to be something that you're going to be given. You're going to be expected that 1 kilowatt equals 1,000 watts. And then some terms down here. These terms are basically the same thing. One is just in metric and one is in US customary. So our metric system, a calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. And then British thermal unit, that's the US customary system, also known as BTUs, is the amount of energy required to heat 1 pound of water by 1 degree Fahrenheit. Also looking at specific heat. So specific heat is CP. You could substitute X, Y. It's just a variable here in this equation. So what you see is Q is your heat, again measured in joules. And what you do is you multiply it by, or you multiply mass in grams by the specific heat amount here. And then you multiply by the change in temperature. And so you'll be given something like 50 degrees, and then it'll increase to 70, something like that. So that change would be 20 then, and you can plug this in. Specific heat is measured in joules per gram degree Celsius. And things like specific heat, you may know about specific heat of water versus air. So for example, it takes a lot more energy to heat up an entire body of water than it would to heat up the air, and we see that daily. So looking at some sources of energy in the United States, again, you need to know that oil is our number one source of energy. We usually use oil, or we use about 70% of our oil for transportation. Coal and natural gas are almost about equal usually, although natural gas is going up. We also use some nuclear, but not like we imagined we would, because people are just kind of afraid of that. And you'll see these other renewables still have a long ways to go before they are a really high source of our energy. And here's our fossil fuels listed over here. Petroleum, again, is just oil. And then here is your alternatives. So a little bit more about alternatives. Make sure you know what this means. So alternative energy sources are just any energy source that does not produce the pollution, greenhouse gases, that fossil fuels do. So you'll notice that most of these things are our renewables. That's probably not a surprise. But so all renewables are considered alternative, but not all alternatives are renewable. So nuclear, for example, is non-renewable because it comes from uranium, which we have to mine, and that comes out of a mineral. Even though we have a lot of it, but it is alternative because it does not produce all of the greenhouse gases that other, coal, oil, natural gas does. That doesn't mean that there's not negatives to it. We'll talk about nuclear energy a little bit later in this unit, but it is an alternative because of greenhouse gas emissions. So when we look at our energy use and what can we do to get more out of our energy, most of our energy that we are producing actually ends up just getting wasted. So if a power plant is producing energy, not only is it producing energy that we can actually use, but it's also generating a lot of heat. Basically, all of the stuff that's being wasted is almost always going to be in the form of heat. So a light bulb, for example, the traditional ones were only about 5% efficient. They gave you 5% light to about 95% heat. So we're getting better about that. See if LEDs are a whole lot better. They're more like 25% light. So our greatest energy sources really are conservation and efficiency. Conservation is basically using it less, adjusting our needs and uses. So for example, if you are, walking around your house, you're turning the lights off as you leave the different rooms. That would be conservation. Efficiency is actually getting more output from your input. So maybe you have energy efficient light bulbs that you turn off as you leave. So you're both conserving and being efficient. So efficiency is more about appliances, things like, you could use dishwashers that are more energy efficient, laundry, those sorts of things. And then you also have something called cogeneration. So cogeneration is this idea that we can capture that waste heat that's like down here for the power plant, and we can use that to heat homes or something like that. So looking at our policy, just like we had integrated pest management, we have integrated energy management. If you remember, energy pest management was all about doing cultivation methods, biological controls, basically anything we could do before we added chemicals, but it wasn't saying we couldn't add chemicals. So integrated energy management is the same kind of thing. You want to try to use alternatives as much as you can, but we also are still going to have to use some of our fossil fuels. So we're not really saying we have to get rid of them all right now. So integrated energy management is mixing our different resources, favoring policies that are sustainable, encouraging conservation and efficiency, those sorts of things. And then you may be curious, where is our research money actually going? Well, a lot of it was going towards nuclear. This is kind of going down a little bit now. Even though 10% of our energy use went to nuclear, again, people were not okay with nuclear because we had disasters like Chernobyl and 3 Mile Island. So it's just kind of not an acceptable thing to the public anymore. 20% of our research is going to fossil fuels and 20% is going to alternatives. So we know that alternatives not including nuclear. So we know that this down here has a very high potential for going up. All right, that's it. Bring your questions. Be ready for